Hello everyone, we are working on the first worksheet of chapter 16, which was on ANOVA testing. Now the first worksheet is just explaining what the F distribution and the F curve was. So this worksheet has some questions to test our understanding of the F curve and the F distribution. So the first question says, how many degrees of freedom does an F curve have? What are those degrees of freedom called? Now, if you recall, the F curve's distribution, which is df, is represented by a pair of values. All right, so it's a pair of values. The first one is the numerator value, and the next one is the denominator value. So how many degrees of freedom does an F curve have? 2 degrees of freedom. So we should say there are 2 degrees of freedom in an F curve. Degrees of freedom in an F curve. What are those freedoms called? The first one is the numerator. The first value is called the numerator value. It's called the numerator value, and the second is the denominator value. Okay, so that's how you would write the answer for the first question. Number 2, what symbol is used to denote the F value having area 0.05 to its right, 0.025 to its right, and alpha to its right? So essentially they're asking the notation to represent F value whose area to the right is 0.05. So we write it as F, and then as a subscript we will write 0.05, F sub 0.05. Any F value, or not just any F value, any Z value or T value which has a subscript of an area, all right, on its, so F followed by a subscript at the bottom represents area to its right. Okay, and that's not just for the F value, that's the case for Z values, T values, chi-squared values, anything. All right, for any distribution. That's just an accepted norm of representing area to the right. Okay, the next one says 0.025 to its right, so you're going to again say F of 0.025, and then alpha to its right, so alpha represents any value of the area, so we'll just write it as F of alpha. All right, it's as simple as that. Now the next one, question number 3, is to see whether you can identify which of these pair of values represent the numerator df and the denominator df. So an F curve has df of 12,7. What is the number of degrees of freedom for the numerator? So the first one, the first value is the numerator. So the numerator is going to be 12, and denominator is going to be the second one, therefore it's going to be 7, right? Number 4 says use table 8 to find the required F values, and then it says an F curve has df equals 6,3. In each case find the F value having the specified area to its right. All right, so essentially they are asking us to find F of 0.01, which this notation represents area to the right, with a df. All right, so with the df equals 6,3. So we are going to refer to our table. Now you can also use a graphing calculator to find these values, but I'm going to show you how we can go to our table and find the values, right? So f of 0.01 with df 6, 3. So let me pull up the table here. Here's the table. Well, this is not quite the table, so let me go back. Here's the table. All right. So this is the F table. This is table 8 in the formula sheet. And our DF was 6, 3. So numerator was 6, right? So the way we had it, it said F of 0.01 and the DF given to us was 6, 3. So the first one is our numerator and the second one is the denominator. So we are going to go to our table first, go across. Now DFN represents numerator, so we have to find 6 in our for the numerator. All right, so numerators are on the top row, so you go across till you get to 6, and then the what's the denominator? It's 3. So this is the column. The very first column is DFD. That means degrees of freedom denominator. So we have to come down to 3, and then it was f of 0.01. So here we have 0.01, all right, as our alpha value. And what is the intersection of 6 and 3 with 0.01? It's 27.91. So in our worksheet, we are going to write 27.91. Our answer is going to be 27.91. The next one says 0.05 is the value of the alpha, so I'm going to write it as f of 0.05 with the same df, right? Df is 6, 3. So let's go back to our table here. So again, 6. Here we have 6, right? For the numerator, let's pull up our pen here. 6 for our numerator and 3 for our denominator. But this time we are going to look at 0.05, the row for 0.05, and that's 8.94, and that's the value of f. So let's go back and write 8.94 for our answer, 8.94. And finally, we have 0.005. So it's going to be f of 0.005 with same df equals 6, 3. Again, going back to our table, we already have 6 and 3 marked. So 0.005 is going to be the last row of this section. So it's going to be 44.84. So 44.84 is the answer. To get a little more practice on this, number 5 says use table 8 to find the required f values. Illustrate your work with graphs for an f curve with df 6, 10, and then in each case find f of 0.05. So I'm going to work out one and I'll leave the other two for you to find from the table using the same methodology, and I'll also illustrate it with a graph. So this time we have a df of 6, 10. So let me just write in proper notation. All right, so f of 0.05 with df equals 6, 10, correct? 6, 10. Now we'll go to the table. First we look for 6, then we look for 10, and then 0.05. So 6 is, we have our 6 here, right? This is our 6. But this time it's not 3 for the denominator, but it's, what was it? It was probably a 10, I forget, right? 6, 10. So, where is 10? Here we have 10, right? So actually we should be looking on the right-hand side table. So we have 6 and 10, and 0.05 is this row here. So the corresponding F value, all right, so it's 3.22. 3.22 is the answer for this. 3.22. All right, now if we are to illustrate this with a graph, remember an F curve is a right skewed curve, and the area will always be to the right because of the notation, the way the notation is given to us. So I'm going to write 3.22 is the areas, right? So 3.22 will be somewhere. Let's just mark it here. I don't know. All right, this is going to be our 3.22, and this area to the right is going to be 0.05. So it is F of 0.05 with DF equals 6, 10. All right, so this is how you're going to illustrate. All right, this is our alpha value. Illustrate your work in a graph. So you can do the other two by yourself for some extra practice, but just follow the way I have shown you to refer to the tables.